Good afternoon, students. Today I am going to discuss about anxiolytics, sedatives and hypnotics. The topics which will be discussed is introduction, the classification of drugs, the site of action, the mechanism of action of benzodiazepines and barbiturates, and the uses of benzodiazepines. Anxiolytics are nothing but the drugs which are used in the treatment of anxiety disorders, which are conditions characterized by excessive or inappropriate anxiety. That is, in people who are suffering from certain kind of psychotic illness, social phobias, obstructive compulsive disorders, etc., they will be undergoing some kind of stress. So in such people, these drugs are used to reduce the anxiety, restlessness, and thereby it will calm the people. Sedatives are nothing but they are the CNS depressants which will reduce the restlessness and emotional tension without producing sleep. In higher doses, the same drug will act as a hypnotic. So hypnotics are the CNS depressants that produce sleep which is resembling to that of natural sleep, and these particular drugs, they will reduce their restlessness, emotional tension, and also they will induce sleep. So hypnotics, they can be used in the treatment of insomnia, sleeplessness, and the difference between a sedative and a hypnotic. Sedatives are the CNS depressants which will reduce the excitement and it will calm the person without inducing sleep. Whereas hypnotics are the CNS depressants which produce sleep which is resembling to that of natural sleep. Sedatives in therapeutic doses, they also have anxiolytic action. Hypnotics, they are used to initiate or they are used to induce sleep in people who are suffering from insomnia or sleeplessness. Most of the sedatives in larger doses, they produce hypnotic effect, whereas the hypnotics in higher doses, it produces general anesthesia. If you see the site of action of sedatives, it mainly acts on the limbic system which regulates our thoughts as well as our mental functions. Whereas the hypnotic, mainly it acts on the midbrain and the ascending reticular activating system which will maintain the wakefulness. Anxiolytic are the drugs which are used in the treatment of anxiety. Anxiety is nothing but it is an unpleasant state of tension or uneasiness which may be due to some known or unknown cause. Like causes may be like the people who are suffering from certain kind of mental illness, or people who are suffering from dreadful diseases, they will be anxious, and the people who are having some social phobias or obsessive compulsive disorders, they always will be under a condition of stress. So that is nothing but a state of tension. So this anxiolytic drugs, they will reduces the tension or restlessness and the hyperactivity which is related to anxiety, and thereby it will calm the person. So when you take the drugs which are used as sedatives and hypnotics, we mainly have the benzodiazepines, the barbiturates, and certain miscellaneous drugs. So based upon their duration of action, we can classify the benzodiazepines as short acting, intermediate acting, long acting, etc. Same way in barbiturates also we have the different classes based upon the duration of action. Then there are also certain miscellaneous compounds which produces anxiolytic action as well as hypnotic action. So this is the chemical classification of anxiolytics, sedatives and hypnotic drugs. So the first class is barbiturates. So these are the drugs like phenobarbital, barbitol, methobarbitol, butyrbarbital, pentobarbital, etc. See, these are all the barbiturate derivatives, and we have just shown a structure of one of the barbiturate, that is phenobarbital. And benzodiazepines class, we have various examples like diazepam, whose structure is shown here. Then chlordiazepoxide, oxazepam, clorazepam, alprazolam, etc. Then there are also certain other miscellaneous compounds which are used as sedatives and hypnotics. First class, we have amides and imide derivatives. Example is glutathione. The structure is shown here. Then alcohols and their carbamate derivatives. We have meprobamate, ethchlorvinol, and the structure of meprobamate is shown. Then aldehydes and their derivatives. We have paraldehyde, triclophosodium, and the structure of paraldehyde is shown. So whichever drug structures are shown, the names are shown by bolded and underlined. So those are the drugs structures which is shown here. The classification of barbiturates based upon their duration of action. So we can classify barbiturates into 4 classes. One is long acting, intermediate acting, short acting, and the ultra short acting. The long acting drugs, they have a fast onset of action is 30 to 60 minutes. Onset is nothing but after you give the drug, within how much time the effect will be produced. So the long acting agents, within 30 to 60 minutes the effect of the drug will start, and the effect lasts for more than 6 hours. And the main drugs in this category is phenobarbital, whose structure is shown here, and methobarbital. The intermediate acting drugs, the onset of action is 30 minutes and they have a duration of 3 to 6 hours. Examples are butobarbital, whose structure is shown, allyl barbital, amobarbital, etc. Then short acting agents, they have an onset of 20 to 30 minutes and the duration will last for about 3 hours. Examples are pentobarbital, hexobarbital, and secobarbital. The structure of pentobarbital is shown here. The ultra short acting drugs, which has a very short onset, that is within seconds the effect of the drug will start and the effect will last for 30 minutes. So the ultra short acting agents, they are mainly used as inducing agents in general anesthesia. So mainly the many thiobarbiturates, they comes under the ultra short acting derivatives. For example, we have thiopentan sodium, methohexetone or methohexital sodium, etc. The classification of benzodiazepines based upon the different properties. So diazepam, flurazepam, nitrazepam, alprazolam, these are all the drugs which produces hypnotic action. Then anti-anxiety action is produced by diazepam, chlordiazepoxide, lorazepam, oxazepam, etc. So the structure of oxazepam is displayed here. And the first structure is of diazepam. Then clonazepam is an anticonvulsant drug, and apart from that, the diazepam, lorazepam, also they possess anticonvulsant action. So most of the drugs, they possess hypnotic, anti-anxiety as well as anticonvulsant properties. So this is the few drugs in the each category: short acting, intermediate acting, and long acting. Short acting triazolam, oxazepam, midazolam, etc. They are the short acting agents. In intermediate acting agents, we have alprazolam, temazepam, lorazepam, etc. And in long acting, we have diazepam, flurazepam, clonazepam, chlordiazepoxide, etc. This is the classification of benzodiazepines based upon their indications or the purpose they are being used for. So when you take certain drugs, so all the benzodiazepines, they have all these properties, but the activity will be predominant. One of the activity will be predominant, like either they may be either showing more of hypnotic action or anticonvulsant action, etc. So these are the, so when you take diazepam, flurazepam, nitrazepam, alprazolam, triazolam and all, they possess hypnotic action, whereas the anti-anxiety property mainly it resides in chlordiazepoxide, diazepam, oxazepam, lorazepam, etc. Then mainly clonazepam, clobazam and all, they are mainly used as anticonvulsant drugs. They are used in the treatment of epilepsy related problems. Now we come to the site of action of this class of drugs. So the wakefulness, it is mainly related to the action of the drug on the midbrain or the reticular activating system. The limbic part is mainly responsible for the thought as well as the mental functions. Medulla, muscle relaxation, cerebellum, ataxia. So the drugs, it acts on the limbic system and they possess anxiolytic as well as sedative properties. So when the dose of the drug is high, it will depress the reticular activating system and thereby they possess sedative as well as the hypnotic effect. Now we'll come to the mechanism of action of benzodiazepines and barbiturates. So these class of drugs, they mainly act on the GABA A receptor chloride ion channel. So this is the representation of the GABA A receptor chloride ion channel. So this GABA A receptor, it has many subunits like alpha, beta, delta, etc. So the various receptors, they are located in the various subunits of the GABA A receptor chloride ion channel. So the GABA A receptor, it has sites for attaching no, sites of binding for GABA, that is gamma aminobutyric acid, which is the inhibitory neurotransmitter. There is also sites for attachment of barbiturates, sites for benzodiazepines, etc. So the barbiturates or benzodiazepines, they will mainly potentiate the action of GABA. GABA is the inhibitory neurotransmitter, gamma aminobutyric acid. So these drugs, when they will potentiate the action of GABA. So when this GABA, when it binds to its receptor on the chloride ion channel, it will cause the opening of the ion channel and there will be an influx of chloride ions from the extracellular to the intracellular membrane. So this influx or the flow of the chloride ions across the membranes, it will lead to the hyperpolarization of the neuron. The hyperpolarization of the neuron, it will inhibit the action potential and thereby the impulse transmission will be interrupted. This is how this particular category of drugs will act. So they mainly act on the GABA A chloride ion channel. So this is the GABA A receptor chloride ion channel. So you can see here there are different subunits like alpha, beta, gamma, delta, etc. So there are various sites where the barbiturates, benzodiazepines, etc. can attach. So there are various points of attachment of the barbiturates on these particular receptor. There are sites. So what will happen is these particular drugs, benzodiazepines and barbiturates, etc., they will potentiate the action of GABA. So this gamma aminobutyric acid, it will bind to the GABA A receptor on the chloride ion channel. So when GABA binds to its receptor, it will be causing the opening of the ion channel. So this opening of the ion channel, it will lead to the flow or the influx of the chloride ions from the extracellular membrane to the intracellular site. So what happens is the flow of this chloride ion across the intracellular to the extracellular to the intracellular membrane, it will lead to the hyperpolarization of the neuron. So the hyperpolarization of the neuron, when it takes place, the impulse transmission is interrupted, and thereby the action potential formation will be blocked. That is how this particular class of drugs will be acting. So the benzodiazepines, they will increase the frequency of opening of the chloride channel, which is being induced by GABA, that is called as a GABA facilitatory action. They increase the binding of GABA, that is gamma aminobutyric acid, to the GABA A receptor on the chloride channel. Whereas the barbiturates, they will increase the duration of opening of the chloride ion channel, which is induced by GABA. That is, they potentiate the action of GABA. So when GABA binds to its receptor, it will cause the opening of the ion channel, and thereby it will possess GABA facilitatory action. At higher concentration, barbiturates can directly increase the chloride ion conductance. So that is called as the GABA mimetic action. Either it can potentiate the action of GABA, or when barbiturates bind to its receptor on the chloride ion channel, it will automatically cause the opening of the chloride ion channel. So that is called as the GABA mimetic action. So they also inhibit the calcium dependent release of neurotransmitters. They depress the glutamate induced neuronal depolarization through AMPA receptors. And at very higher concentration, that is in anesthetic doses, they depress the voltage sensitive sodium as well as the potassium ion channel. So the net result will be the hyperpolarization of the neuron, inhibition of action potential, and thereby they produce the CNS depressant action. Then what are the uses of this class of drugs? One is they used to reduce the anxiety. At lower doses, the benzodiazepines are anxiolytic. They reduce the anxiety, that is by enhancing the transmission of GABA in the neurons, and having the alpha 2 subunit in the GABA A receptors. They inhibit the neuronal transmission in the limbic system of the brain. And this anti-anxiety effects of benzodiazepines, they are less subject to tolerance than the sedative and the hypnotic effect. What are the uses of benzodiazepines? So will come to the conclusion of the uses. All the benzodiazepines, they have sedative as well as calming properties. That is, they will reduce the restlessness, anxiety, as well as they will calm the person. That is mainly in people who are suffering from different kinds of psychotic illness. So psychotic illness means schizophrenia, maniac disorders, bipolar disorders. There are different types. So the major thing is those people will be restlessness will be there. So they have to calm the person in people who are suffering from a different kind of psychotic illness. Then they also produce hypnosis at higher doses, that is in people who are suffering from insomnia or sleeplessness. These particular drugs, they produce hypnotic effects, so they produce sleep which is resembling to that of natural sleep. And in higher doses, they cause anesthesia. So the dose should be calculated according to the individual need. They also have anxiolytic property, that is they reduce the anxiety. Then several benzodiazepines, like for example we have told about clonazepam and all, they have anticonvulsant property. Anticonvulsant is nothing but the drugs which are used in the treatment of different types of convulsions, like epilepsy. There are different types like grand mal seizures, petit mal, psychomotor epilepsy, like that. There are so many different kinds of epilepsy. So in the different kinds of epileptic people, these particular drugs, they are used to reduce the convulsions or seizures. Then they also possess muscle relaxant property. They will relax the spasticity of the skeletal muscle, and thereby they produce the muscle relaxant property or anti spastic drugs, like that. Then treatment of insomnia. Insomnia is nothing but sleeplessness, that is nothing but related to hypnosis. Mm, then they also reduce the withdrawal symptoms in chronic alcoholic people. So the chronic alcoholics, they also show the kinds of restlessness, anxiety and all those things. So they are used mainly to reduce the restlessness and anxiety in chronic alcoholics.